Welcome students. In this video we are going to begin with chapter 6, that is lines and angles, which is actually belonging to geometry. We all know geometry is branch of mathematics which deals with shape. Is it okay? And we have studied many basic concepts in earlier standards. So let us quickly recall. So basic terms and definitions in geometry. So first is point. Now what is point? Point gives exact location. It is dimensionless and it is represented by a dot and symbolically represented by a capital alphabet or capital letter. Is it clear? Then line. What is line? So it goes, actually it is set of points. It is set of infinite points which goes endlessly in both the directions. So that particular structure is called as line. Is it okay? And line can be defined by any 2 points on it. So if A and B, so we call this as line AB. We call it as line AB. Earlier we used to write or give the symbol like AB and then 2 arrowheads like on the top. But now in 9th standard we will not represent line by using this particular symbol, but we'll simply write it as AB. What are AB? AB are any 2 points on the line. This is one way. We can have another way of representing line, and that is by using small case letter L, which is shown beside the line. Is it okay? So what is line? Line is collection of point which goes endlessly in both the direction, and that's why arrowheads are marked on the on both the sides. Okay. So now when we talk about line, first thing, it has one dimension, that is length. Is it okay? So line has one dimension and it has no end. It goes endlessly. So let us summarize the points. So line is set of infinite points which goes endlessly in both directions. It is one dimensional. So point was dimensionless, but line has one dimension. Is it okay? And it is collection of points. Now something more, more points about line. So we say line segment and rays are the parts of lines. Is it okay? So suppose we take 2 points A and B, and if I join these 2 points, if I join this point by a straight distance, that is the shortest distance, then we call it as line segment. Is it okay? If I extend this line segment, then I'll get a line. So we say line segment is part of a line, isn't it? Similarly, if I talk about a ray, if I draw a line and then if I just consider this particular portion, then I'll say that this is what? Ray. Is it okay? Which goes endlessly in one direction and it has one end point which we call it as starting point. So ray and line segment are parts of the lines. Is it clear? Now, if I have 2 points, then how many lines can be passed through these 2 points? So we say one and only one. There can be one and only one line passing through given 2 points. Can we have another line passing through these A and B points? So we say no. Similarly, if I talk about a single point, so how many lines I can draw passing through the same point? So through one point there can be infinite lines. So from 2 points, how many lines can pass? One and only one. From one point there can be infinitely many lines passing through the point. Such lines are called as, which are intersecting each other at one point, they are called as concurrent. What we call it as concurrent lines. Is it okay? You must have heard this particular term. So lines, many lines, more than 2 lines passing through one point, then we call it them as concurrent line. Otherwise, if 2 lines are there, we call them as intersecting line. Is it clear? So let us summarize the points. So first, line segment and ray are parts of the line. Then infinite lines can pass through a point and one and only one line can pass through given 2 points. Now these particular properties are very important for us now. Is it okay? So from 2 points, one and only one line can pass. Now when we talk about one line, it is okay, but more than one line, then we can have parallel lines and intersecting lines. So what are intersecting lines? They meet at a point. And what are parallel lines? They do not meet each other. Is it okay? Now let us go for some more important terms. So if I draw a point A, if I draw a point B and I try a third point C. Now if I am able to draw a single line through these 3 points, now how many points I am talking about? 3 points. That is more than 2 points. More than 2 points, and if these points lie on the same line, then such a points are called as collinear points. If 3 or more points, minimum how many points we are talking? 3 or more points lie on same line, then they are called collinear points. Now why this condition 3 or more? We have just now seen that 2 points, there can be from 2 points there can be one line. One line can pass through given 2 points, isn't it? That means 2 points, they are always lying on a line, so they are always collinear. What about 1 point? So there are infinitely many lines, so it is always lying on a point, so there is no question of collinear. So for defining collinearity of points, we talk about minimum 3 points or more than 3 points, because 2 points are always collinear. They are collinear by default. Are you getting? So if 3 or more points lie on the same line, then they are called as collinear points. Here, if 3 or more, this term is very important. Is it clear? So for 2 points, we say that it is by default. Is it okay? And why by default? Because from 2 points, one line will be there which will pass through those 2 points. Okay, now coming to the next part. So I have drawn again few points, so A, B, and now the third point C. Now try to draw a single line from this point. Is it possible that we can draw a line which will contain all these 3 points? So it is not possible. There cannot be a single line which will contain these 3 points. So such a 3 points or more than 3 points, they are called as non-collinear points. So we define non-collinear points as points which do not lie on same line are called as non-collinear points. So now A, B, C are non-collinear points. What about 2 points? Is it possible that they are non-collinear? It is impossible because they are collinear by default. So definition of collinear and non-collinear point has to be understood properly, and why do we use the term 3 or more than 3? That has to be understood more prominently. Is it okay? So children, pay attention to each and every word in geometrical definitions of geometry. Is it clear? Now the next is angle. Now angle, what is angle? So we say when 2 rays originate from a common vertex, then the structure is formed which we call it as angle, and the common point is called as vertex. We have denoted it by O. Now here vertex is what? Vertex is a point. It is a spatial point wherein 2 rays, 2 line segments, 2 lines are intersecting or meeting. Is it clear? So every vertex is a point, but every point is not a vertex. Are you getting? So O is a vertex because 2 rays are originating from this particular point, and that is called as vertex. When we talk about vertex is actually the identification for that particular angle. The angle is always identified by its vertex. Is it okay? So now let us put it in the form of words. So the angle is formed when 2 rays originate from the same starting point, and the common starting point is called as vertex. The plural is vertices. We have indicated it O. Now we will define the another point on the rays A and B. Now the rays forming the angles are called as arms of the angle. So which are the arms in this particular angle? OA and OB. Now can I say it as AO and BO? So you must remember that ray cannot be, or letters in rays cannot be interchanged. If the ray is OA, that indicate that starting point is O. The name of the ray always starts with starting point and you cannot interchange its position. So which are the arms here, children? OA and OB. And how will you name the angle? So symbol that is for angle is angle O, you can say, if there is only one angle formed, or you can say angle AOB. The vertex should be in the middle, or you can say it as BOA. The end letters can be exchanged, their position can be exchanged, but middle letter should be the vertex. As I told, angles are identified by their vertices. Is it clear, children? So remember now this basic for angles. Now types of angles, so you must be recalling types of angles also. First is zero angle. Now zero angle is what? So we know that angle has always two arms. So if two arms are there and there is no movement of the arm has not moved, second arm. So we say that there is 0 degree. Is it okay? And it is represented in this way. Then coming to the acute angle. So acute angle means its measure is between 0 to 90 degree. 90 degree, that is right angle. So we indicated with a box. Its measure is 90 degree. We call it as corner. Is it okay? Then obtuse angle. It's a little bigger than right angle and less than straight angle. Then straight angle is 180 degree. Then complete angle also, you know, that is 360 degree. And the important angle, which is reflex angle. Now what is reflex angle? So if I have drawn an acute angle and outer portion, now see the movement. Is it okay? So ray movement, outer portion of this particular angle, we call it as reflex angle. And its measure is always between 180 degree and 360 degree. It is more than 180 degree, less than 360 degree. Then how to find out reflex angle? So you will easily notice that this outer portion plus inner part of the angle, together they will form complete angle, that is 360 degree. So if this particular angle is 40 degree, then what is the measure of reflex angle? So reflex angle will be 360 minus 40 degree, that is 320 degree. Is it okay? So how did you understand how to calculate reflex angle if the inner part of the angle is given? We can have one more example. If it is a right angle, then can we have reflex angle? So yes, and its measure will be 360 minus 90, that is 270. Can we have reflex angle associated with obtuse angle? So yes, if it is 120 obtuse angle degree inner measure, so it will be 360 minus 120, that is 240. Are you getting? So reflex angle is outer part. So we can say every angle is associated with outer part, and that can be the reflex angle. Am I clear, children? So let us summarize this in the tabular form so that you can write that table and use it forever. So now zero angle, measure 0 degree. Acute angle, measure lies between 0 degree and 90 degree. Right angle, measure 90 degree. Obtuse angle, measure lies between 90 degree and 180 degree. Straight angle, measure is 180 degree. Reflex angle, measure lies between 180 degree and 360 degree. Complete angle, measure is equal to 360 degree. Now how will you indicate 360 angle? So let me draw the figure. So here you will find, if you want to show the reflex angle, complete angle, then it will be shown it like this. So 0 degree, there is no movement. 360 degree, complete rotation. So this is representing complete angle, that is 360 degree, and this is representing 0 degree. So I hope you have understood the types of angles very well, because we are going to use these concepts in understanding further concepts. Now pair of angles. So complementary angles, the sum of two angles is 90 degree. Then supplementary angle, sum of angles is 180 degree. As we are talking about pair of angles, so we are talking about two angles at a time. So sum of measure of two angles is 190 degree, then they are called as complementary. If the sum of measure of two angles is 180 degree, then they are called as supplementary angles. Then adjacent angles. Now adjacent angles, so first angle, and then we have named the arms and then another ray. So here how many angles you can see excluding reflex angle? So we can see angle AOB, angle BOC and angle AOC. What are adjacent angles? So again they are pair. It is actually this particular pair of adjacent angle have two angles which has common vertex, which has common ray, and the non-common arms, they lie on different side of common ray. If these three conditions are satisfied, then those two angles are called as adjacent angles. Are you getting? So here which angles are adjacent angles? So we say angle AOB and angle BOC. They are adjacent angles. Which one? This one and the lower one. What about angle AOC and angle AOB? Are they adjacent? So now angle AOB and angle AOC, they have common vertex O, yes. They have common arm, yes, OA. But the non-common arms, which are the non-common arms? OB and OC. They are lying on the same side. So AOC and angle AOB, they are not adjacent angles. Is it okay? So for two angles to be adjacent, three conditions should be satisfied. They should have common vertex, common arm, and non-common arm should lie on different side. This condition is also narrated as they should have non-common interior. The interior of AOB, what is interior of AOB? So this is interior of AOB. And what is interior of BOC? So this is interior of BOC. It is not common. Is it okay? So therefore AOB, angle AOB and angle BOC are adjacent. But on the other side, if we talk about angle AOC, I am representing it with green. And if we talk about angle AOB, if I represent it with red, do you think that some portion is common? Are they having common interior? So yes. Can you see the portion shaded with green as well as red? That means AOC, which angle? Angle AOC, that is the bigger one, and angle AOB, they are not adjacent angles. Same figure, but there is only one pair of adjacent angles. Is it okay? It is very important to understand the concept of adjacent angles. I hope you have understood it very well. So we will write it. So two angles are adjacent if they have common vertex, common arm, and non-common interior or non-common arms lie on either side of common arm. So if all these three conditions are satisfied, then only those angles are called as adjacent angles. If any one condition is not satisfied, the angles are not adjacent angles. Is it clear, children? So work on this concept of adjacent angles. Now next is linear pair. Now again I am drawing two angles. See what I have done? I have drawn here two angles and the non-common arms. Now which are the non-common arms? First you tell me whether they are adjacent angles. So let us say take a question here. Do they have common vertex? So we say yes, they have common vertex O. Do they have common arm? Yes, they have common arm OC. What about non-common arms OB and OA? Are they lying on the different side? Yes, they are lying. So these two angles which we have drawn, they are adjacent angles. Which two angles? Angle AOC and angle BOC. They are adjacent angles. Now these adjacent angles, which are the non-common arms? BO and OA. Look at BO and OA. Are they forming a line? See, are they forming a line? Yes. The non-common arms, if they are forming a line, then what do we say? Those adjacent angles are forming a linear pair. So what is required? Two adjacent angles and their non-common arms should form a line. Then you get a linear pair. So linear pair is adjacent angle. It is pair of adjacent angles. Is it okay? And non-common arms are forming a line. So let us quickly summarize. When non-common arms of adjacent angles form a line, then the angles are called linear pair angles, and angles in linear pair are always supplementary. As line is formed, what is the sum of those two angles? So it is naturally 180 degree, and 180 degree means supplementary. Is it clear? Then vertically opposite lines. So if two lines are intersecting each other, which two lines, AB and CD? Is it okay? So there is formation of four angles. Can you see the four angles here? So the formation of four angles at the vertex, and that particular angles, yellow marked, so those are vertically opposite angles. These angles are called as vertically opposite angles. Why? Because their vertex is common and they are on opposite side of each other. And the vertically opposite angles are always equal. So we say when two lines intersect each other, then there is formation of two pairs of vertically opposite angles. And vertically opposite angles are always equal in measure. Is it okay? I hope you have understood this concept, children. Work on this concept and try to recall the concepts which you have studied earlier, because these concepts we are going to use for further concepts in lines and angles. Thank you, children.